I'm Milind Deshmukh, representing two companies, MD Transcon Pvt Limited and Australia Energy Infra Private Limited. I welcome you all on behalf of my companies. The introduction, in short, my presentation would be, flow of my presentation would be like this. First, the brief of companies, then some of the important projects in a 3 to 4 slides we are doing, have been doing, or we have completed for the government of Maharashtra, Odisha, or in India. Then I will touch to the, in this 1 or 2 slides, I will touch to the sustainability. Then portfolio, then to achieve the sustainability by 2070, we will explore the portfolio of solution. Then I will be closing down with this energy efficiency in short, and finally it is going to the conclusion. So as far as the introduction, this MD Transcon Pvt Limited is concerned, we exclusively were working in a domestic market for the transmission line, for the substation, for the gas insulated substations, and doing a lot of jobs on a pan-India presence. This is the brief in short. Then this is the second company, Australia Energy Infra Private Limited, is largely focusing on the export market in the same T&D sector. And then factories being set up, almost factories ready for the smart energy meter. We are ready with our 10 to 15 numbers of prototype of the smart energy meters, which is thoroughly connected to the HES, MDMS, and all the metering data is routing via SIM, SMS to the HES, MDMS system, and meter will be sent for the NAB, the CPRI testing, this whatever the required to the IRIDA, whatever the required testings are there. I would move forward, and as I explained, some of the projects we have done or have been doing. This is the one of the important project we did for Mumbai Metro, and unless we complete this project, this was diversion of pylon shifting. It was a pylon shifting work and connecting it to the AEML Adani switchyard with a EHV cable using this receiving substation. So we just completed the job, and unless we complete the job, metro laying of metro track 3 or the car shed construction wouldn't have been possible. Second one project we are doing for the SIDCO. The challenge in this particular project was the power evacuation from Uran to Kharghar via receiving station at Wagivuli, which is being constructed by the General Electric G, and diverting this 220 kV line as per the requirement of aviation industry and as per the requirement of marine navigation for Navi Mumbai International Airport, NMIA. So options initially before starting this work, options considered were like laying construction of a steel bridge with a power cable. That was the first option, because it is a continuous creek of 1.5 meter having at least 6 to 7 meter of water depth. So initially government of Maharashtra, SIDCO on behalf of government of Maharashtra decided to construct the steel bridge, and Mahatransco was to lay the cable from the steel bridge, EHV cable from the steel bridge. Second option was the submarine power cable, which is never explored in India. In San Francisco Bay or somewhere in Italy, they have been transmitting, evacuating the power using the submarine cable, undersea cable. So these were the options considered. Steel bridge construction from SIDCO in a deep sea creek, and then laying a 220 kV cable. The project would have been some of this kind. SIDCO would have constructed the steel bridge, and the cable would have been laid from the steel bridge. The cost of this project turned out to be somewhere around 450 CR. Then second option was laying the submarine cable. This would have passed through the seabed, likewise this. And this would have led, likewise this sort of project is never completed in India, and the associated cost, time delay, challenges would have been time delay, then your high maintenance cost, then your cost was somewhere around 900 CR. So then somehow earlier option and these options, even if it was explored, but it hasn't got through due to the clearances from the environment or due to the n number of problems. Then we decided to explore other option with a knowledgeable engineer of Transco, chief engineers, superintending engineers, and the engineers working on the field, and as per the direction from the director. So we just explored, diversion of this line and giving power to supply to this gantry. This is a gantry. So from location number 86 to the 86 and then 86A, simply we put two towers. In new tower, if you can look at the new tower that was in the deep sea water, and two towers been placed on the island, and finally we got through and connected. Almost it is on the verge of completion, not yet completed. Cost is merely 40 CR. So in turn, we would say that we have almost saved more than 400 CR of government of Maharashtra for the evacuation of power and diverting this line as per the requirement of aviation and navigation industry. So next, this challenging project is on the verge of completion. Then moving forward, these are some pictures of pile foundation. This is the jetty constructed. You will come to know the gravity and complexity of this project. And this is the Honorable Secretary Dineshji Agmare visiting the site, directors and chief engineers. This is all about the important projects or the projects we are doing in Maharashtra or in India. Now, as the theme of the program goes as a sustainability, then energy efficiency, then decoding the smart solutions. So I am coming to sustainability. I have already explained the sustainability. Still, sustainability in different words would be, there are three pillars of sustainability. This is economic viability. That is what I was referring to. First P, profitability. Then social equity. Second pillar is the social equity. I was referring to it as a peoples. And then environmental protection, I was referring to is the third P, as a planet. So if we look at all these three pillars, then solution will come out as a bearable, equitable, sustainable and viable. So this is what sustainability is. Already I explained to you addressing the needs of the current generation. This is what all about sustainability and sacrificing the needs, with not sacrificing the needs of the future generation. And then the protection of the environment. This is what is sustainability is. Now why we started thinking about the sustainability? It is the major chunk of thermal generation, fertilizer industries, then what we call it, cement industries, then making the pollutants, and we are at number 3. So if left side if you look at the left side, it is a CO2 emission, or we can say GHG, greenhouse gases emission. So and then transportation industry is also contributing to the emission and GHG emission. Then it is finally it is going to be the agriculture also contributing to the GHG emission. So what could be the solution? If you look at the right side, then you will find this solar farm, then you will find a wind farm, then you will find a lot of plantation. So this is going to be the future. if we aim for the sustainability, and this is going to be the future. So anyhow, we have to extend the stake. You have to rise the stake of this green energy to achieve the sustainability by 2070. Sector-wise GHG emission in India. If we look at a sector-wise GHG emission, electricity production is almost contributing to 44%. So this is going to be the the major area wherein we should be looking at. We should be taking all the efforts, and we should be reducing the stake of this thermal energy. Then it is a transport, industrial process, then agriculture, and then waste. So now this is the challenge, and we have to somehow obtain, we have to somehow try for the sustainability and have the solution and achieve a net zero emission by 2070. Then what are going to be the portfolio of solution? So if you look at the portfolio, someone Mr. Kakuji was talking about the CCUS. This is the concept, and unless we go for the CCUS, I will explain to you what that CCUS is. First thing is going to be energy efficiency. With the decoding of smart meters, smart grids, everyone will be very much familiar. I have to be energy efficient. I should be using, in the last month I was using 500 units. This month I should be using 400 units. If you have the tools in your hand to monitor what is my yesterday's consumption of this electricity, so you will be able to reduce the consumption of the electricity. You will be the energy efficient person. So energy efficiency and all the effort should be on to achieve this energy efficiency. Then it is going to be the renewable energy, and finally it is going to go to be the CO2 capture. That is what CCUS. Before 4 or 5 days, I have seen one seminar going on in IIT, and all we are discussing about the CCUS. Now CCUS is the important, and this is the important. If we look at the loose plastic flying here and there, then we look at the fly ash. Dr. Anbalgan sir was talking about the fly ash and how to dispose it off is again challenge. So capturing this type of loose material which contributes to the carbon emission and converting it into the construction of what we call it buildings, then blocks. So this is going to be the converting it in a solid form and using it. This is going to be the CCUS. So portfolio of solution could be energy efficiency, then renewable energy, and then carbon capture, utilization and storage. As far as this green energy is renewable energy is concerned, just points to ponder are like, can every house, because Wagmarai Sahib, Honorable Wagmarai Sahib, he was talking about the non-availability of land or the huge cost of the land. So I have seen in China, I have seen in USA, the individual houses having the solar rooftop generation. We can just think, can every house, society or village be equipped with a rooftop solar? 1 kilowatt, I gotten this data. 1 kilowatt needs 100 square foot of space. So even if we have 1,000 square foot of constructed area, and we can simply build 1,000. So you will be manufacturing 10 kW. Now, assuming 1 million houses are equipped with a solar rooftop, then 10 kW into 1 million. Simply, I am taking example 1 million, that is 10 lakh. So 10,000 megawatt, we can have a 10,000 megawatt. So serious thought should be given to the efforts should be made to equip the houses with the solar rooftop generation. As far as other avenues are concerned, hydro and wind, again point remains, are we using resources to generate the power to full potential? Then as good as hydro and wind is concerned, are we using the resources to generate the power to full potential? I was talking to, even in my first piece, I was talking about the policies. There is a policy for 5 megawatt, but there is no policy. Then Mr. Kakuji was talking about the green hydrogen. We have visited, 1 year back, we have visited one Karanjwan substation. Voluntarily, we did the survey. It is a 3 megawatt and it is still idle. Since last 4 years, that generating station is idle. We went there, then gave our proposal as per the Go MWD policy. Then we said that there is enough land bank, and even the solar can be merged with this hydro, and even we can have 5-7 megawatts from the same place, because government has a huge land bank. So wherever they find a land, people are coming with that floating photovoltaic cell. So wherever we find the land bank, let us utilize it. If it is from the government, let us utilize it, and let us go for the green energy. If the policies are not available, then expression of interest, publishing it to the lot of newspaper, then website, it is going to be the option. But it should be concluded. This is the overall picture of this Karanjharam Dam. As we visited, we simply took a picture, and it is still idle. We just wanted to urge policymakers to make it operational, and let us not waste the green energy, and let us even the hydrogen can be, the location is such a good. If we couple this hydro with what we call it solar, and then we can easily generate the green hydrogen at the same location, because they have the enough of land. Moving to the next point, new initiatives. As we have put up our stall, and new initiative was about the. It is about the energy, increasing the energy efficiency. So as far as energy efficiency is concerned, the smart energy meters, postpaid and prepaid, we have already launched it. We will be shortly testing it, or on the verge of testing, and we will be ready with our commercial production from the April 2023. So it is a. So what are the components? Smart energy meter, it is either postpaid or prepaid. In some of the time where we do not get the what we call it that signal, when sometimes in the malls, sometimes in the it is a G-3 or -3, -4, -5. There we cannot get the signal. It is down to earth. It is in the basements most of the time. Signal these meters, smart meters. Then we will have to install one DCU, data concentrator unit. Then SIM is going to be there, and this is a automated metering infrastructure connected to HES MDMS. We have already connected meter from here to HES MDMS in Singapore or HES MDMS in Bangalore, and the data is transmitting via that channel. Then it will go to connected to the utility billing, and individual mobile app we couldn't develop. Individual person, individual customer can have the mobile app and can monitor the usage of this electricity or the. And then finally it is going to be the payment by customer. These are the this thing. This is going to be the smart meters, then either connected with the neighborhood area network or the wide area network or a SIM, GPRS, and it will go to the HES MDMS, and from HES MDMS that data will be scrutinized, and from that meter data management system to utility. And at the same time, you will have it on your mobile app. Moving to next slide, benefits. Theme of this program is the smart decoding, the smart technology, smart grid. Whether it is going to be the game changer? Yes, it is going to be the game changer. I haven't seen the distribution utilities there. Most of the time, generation is depending on the what we call it distribution, or even the transmission is depending on the distribution, because these are the peoples, they get a fund, and that fund is to be routed to the either distribution or generation. So with the the emergence of these smart meters, initially even if we have it postpaid, but down the line if we have prepaid, so whatever the collection, 10,000, 15,000 crore rupees, whatever the monthly collection is there, we can have it in advance, and then it is going to be in short, it is going to be the game changer for the utilities. Once we have the utilities, means DISCOM, once we have the equity in advance, this DISCOM will be able to fund it to the generation or transmission. So everything, I suppose, the problem can be resolved. So this is going to be the game changer. It is a big task. We just want to complete it by 2027, but let us try for that. Maybe 2028 or 2030 you will be able to complete it. So what are the advantages of smart meter? It is a real-time data, most of the day, tampering intimation you get, then theft control, whatever, as far as utilities are concerned. Increase in a monthly revenue, definitely it is going to be the increase in monthly revenue. The complete outsourcing, most of the time you are sending your, this meter reader or someone to take a picture and then print the bill and, then the collection of this thing. So automatically it will happen. Complete outsourcing, effective monitoring and control will be there, aligning, and this particular project is aligning with India's digital vision. Because we want to be digitized, India want to be, digitization, we are going for the digital. Benefits of smart meter to the customer. Total transparency from the utility. He can, the respective customer can monitor what is my today's consumption, what is my yesterday's consumption, day before yesterday's consumption. So, and then real-time unit consumption on app, because the moment it goes to HES, MDMS, it will come to your app and you will be able to monitor it, yes, what is my yesterday's consumption. Then customer can save a cost. We can be energy efficient. When the peak demand is there, then we can simply put on the light, put on the AC, and we can be energy efficient. So, to achieve, my humble request to achieve, as we aim for the sustainability, we have to be energy efficient. So it is the our individual responsibility of the Indian peoples to use these energies very wisely, because energy is at the end of the day life. What we call it, energy is a life, and the energy saving is a life saving. So we have to be very much serious about the consumption and the utilization of energy. The ease of payment using app, you need not to have your, the printout bill and then you should be paying. From the app, you can pay, whatever the bill amount is there, whatever the consumption is there. Then time saving and efficient use of energy. Moving to next slide. Conclusions. This is finally going to be the conclusion. The energy sector can contribute to net zero emissions, switching over to the green energy wherever possible. Then next, the innovative technologies. We were talking about the innovative technologies. So innovative technologies, products and services. For example, smart meters, smart lighting, smart grids needs to be adapted to achieve the energy efficiency. And finally, pledge I have already given to you. Let us explore the innovative ideas. Let us explore the technological advancement. Let us be energy efficient and use the sustainable solution wherever possible. Let us make this planet pleasantly livable for our generation and the next generation to come. With this, I conclude and thank you. I'm Milind Deshmukh on behalf of MD Transcon and Ashtavinayak Energy. Thank you very much. Thanks for your time, sir.